I built an AI agent that rewrites its own prompts, and within minutes, it learned how to cheat the test. We'll talk about that in a moment, but first, So anyway, I built an AI agent with a scoring system and an improvement loop, but instead of getting better, it started immediately embedding the scoring criteria directly into the new prompts. So even though the score went up, the quality actually didn't. So this phenomenon is known as Goodhart's law. When a measure becomes the target, it ceases to become a good measure, and we saw the LLM figure this out and do it in real time. On most AI agents, the system prompt, or the behavioral prompt if you will, is static from the day the developer wrote it and deployed it. And so even though things might change with user interaction, the AI agent never really gets any better. So to solve this problem, I came up with 3 features that we're going to add on to an existing AI agent harness. Firstly, we need a scoring system that takes in the user question and the LLM output back to the user, and based on 4 criteria, we'll score the output and give it a 1 to 10 rating. We'll score each interaction pair on relevance, completeness, tool calls, and tone, which is how concise and direct the answer was. Secondly, I needed a way to store these new prompts, so I built a prompt versioning engine. And then finally, we'll need an evaluation pipeline that takes in all of those scores and figures out what things could be improved based on those scores, and rewrites the prompt, writes a new version, and puts it into the pipeline for the loop to continue. So to do this, I partnered with Inngest Durable Workflows. They have a fork of an AI agent harness that kind of does everything that we need it to do, and their durable workflow engine allows us to do async scoring so that it doesn't block the user path. Also allows us to put each of these steps into its own retriable function, so expensive calls don't have to be redone if they were successful. And finally, allows us to set up a cron run for the evaluation pipeline, so we don't have to mess with a cron engine on the side. As I said before, the scoring is an async event. It should not block the user from receiving the response immediately, so that is something that is done off the user path. With the prompt versioning system, it allows us to detect underperformers based on their cumulative score and overperformers, and we can downgrade the amount of traffic that the underperformers get until they get completely eliminated, as well as promoting the best performing prompts. The evaluation pipeline is really the heart of the whole system. So its job is, of course, to take in all of the scored interactions and determine what needs to be done to the new prompt to make it better. Relatively simple task in theory, but I did have to put quite a few guardrails in to make sure that the whole system didn't spiral. A lot of simple things like requiring at least a certain amount of new data before it created a new prompt so it wouldn't refit on old data over and over again. I also discovered pretty quickly that we needed 1 child prompt per parent prompt, so if you had version 1, it would continue making new versions off of version 1, again, kind of overfitting. So there was just a lot of little things like that that were required to make this work. So with a lot of trial and error, I did get the system working pretty well, but there were a lot of things that we found out that broke pretty easily that needed to be fixed. So here's our learnings. So the main one, as I kind of hinted to at the beginning of the video, is guardrails really, really matter. So almost immediately, the LLM figured out how to cheat the scores. First, by embedding the scoring criteria directly into the new prompt. So it would literally give the new prompt hints on how to improve its tone based directly off the scoring criteria. Again, Goodhart's law. And then the user answering agent would see that, and it would tune its responses based on the scoring criteria itself, which would make the LLM-As-Judge see that that was working and continue adding more of those type of cheating elements, which basically created a recursive loop failure, and it just kept getting higher scores even though the quality of the output was actually way worse. So that was luckily pretty easily fixed with a critical rules section in the prompt. What's crazy about this is it happened within probably the 1st or 2nd revision. This wasn't hours worth of iteration before it figured out how to do this. The LLM-As-Judge figured this out basically on the 2nd version, which in my mind is pretty crazy that it was smart enough to figure that out. The second thing we learned is that gains are pretty marginal if you're using frontier models. It's very incremental progress. But what this does allow you to do is take a cheaper, smaller model that generally might not be smart enough to effectively do a lot of tasks. And with the evaluation pipeline and the improvement, these smaller models can get substantially smarter, especially if you're using a larger, more expensive model, such as like a Claude Opus as the LLM-As-Judge, and it's feeding new and improved instructions down to the smaller model. One thing I did not account for this simple test was token efficiency. So the evaluation pipeline does not track whether the new versions are more token efficient or not, and that would actually be a good production use case. And another scoring metric is how well the new prompts use tokens, input and output. The final learning is I did use LLM-As-Judge as the scoring mechanism, but there are some shortcomings with having AI judge its own output, even if it is a different model, and there are some better options out there for a more complex system. So the most complex system, but also the best, would be actually getting product outcomes from the product itself. So if your product is requiring user signups, or a user accepts or denies a message that was sent, if you can actually track those outcomes and score based off of those, that would be your best signal overall. Setting that up requires a lot of complexity, but if you are using a platform like Inngest, funneling those actual product signals back into the loop is actually possible. Another simple but much more manual process is having a human in the loop. So every time a message pair comes through, a user input and an LLM output, you have some sort of mechanism where a human can say whether it was good or not and score it manually. Another more complicated thing you could do is the auto research methodology, where a separate workflow spins off a new loop and gathers additional context to build the new improved prompt. So an example of this would be in our Kubernetes question example. The second auto research loop could reach out to the Kubernetes docs and pull down what those docs say about the question and be able to reformulate a prompt based off of that. So in summary, if you want to build your own self-learning agent, I do have the full code repo as well as a full write-up on how I did this on the Inngest blog. That'll all be in the description. But in summary, what we did here, take an existing AI agent harness that works well, and we add scoring to it. We add prompt versioning, which allows A/B testing, and we add an evaluation pipeline that takes all of this information and creates new and improved prompts and then puts them into the versioning. All of these mechanisms are decoupled from the actual user interaction, which means there's no delay there on the user getting their answer back. We have async functions running on the durable workflow platform that allows us to do all of this in the background. And then we have a ingest function cron that allows the evaluation pipeline to run on its own schedule as well. So all this can be done behind the scenes. So using a durable workflow platform like this is a force multiplier, because instead of dealing with orchestration and infrastructure, we just put in the tasks that we need done and how they should be done, and it allows us, the engineer, to instead be able to tell our agent what is good and what is not. Definitely clone the repo and swap in your own behavioral prompt and let me know how it works for you. We'll see you later.